Greetings, Earthlings. So I've got my first update for you on my research of the climate and climatology. So first, let's talk about what the climate is. To understand what the climate is, you have to understand what the weather is. So the weather is generally the state of temperature, humidity, atmospheric pressure, wind, and precipitation in a given area at any given time. That would be the weather conditions of that area. Climate refers to an average of weather conditions over a period of time. I read generally 30 years, but I'm not entirely sure how accurate that is. But climate is the average of the weather conditions over a period of time, so that's the difference between climate and weather. Climate science is the study of the climate, so we're studying the average of weather conditions over a period of time and how that average changes as time goes on. A region's climate is said to be dictated by its, quote, climate system. The climate system of a region has 5 components. The first is the atmosphere. The second is the hydrosphere, and then the cryosphere, the lithosphere, and the biosphere. So starting with the atmosphere is the layers of air above the Earth's surface, which are contained via Earth's gravity. And the atmosphere is distinguished from the Earth itself because the atmosphere is primarily in a gaseous phase, whereas the Earth's surface is a solid phase. The hydrosphere is defined as the combined mass of water found on, under, or above the surface of the planet. So the hydrosphere is, in general, the water on our planet, including within the atmosphere. The cryosphere is similar except regarding ice, so solid water, and there appears to be overlap between the cryosphere and the hydrosphere. I'm not entirely sure if the hydrosphere includes solid water. I'll have to do more research on that, but I believe that it does. The cryosphere is specific to solid water. It is, quote, the portions of Earth's surface where water is found in solid form. That's the cryosphere. So the atmosphere, the hydrosphere, and the cryosphere having to do with air and water. And then there's the lithosphere, which has to do with solid mass, particularly or specifically, quote, the rigid outermost shell of a terrestrial type planet. So on Earth, that is the crust and the uppermost portion of the mantle, which is primarily stable and solid. And then the biosphere has to do with all ecosystems on the planet. So ecosystems are the communities of living organisms, quote, in conjunction with the non-living components of their environment. So the biosphere is generally the sum of all life on Earth and all of the things that life depends on, and all of the aspects of the environment in which that life interacts. So the climate system is accumulation of all of those things: the atmosphere, which is the air; the hydrosphere, which is the water; the cryosphere, which is the ice; the lithosphere, which is basically the crust and the surface; and the biosphere, which is all of the living material on the planet. Climatology is a branch of the atmospheric sciences and a subfield of physical geography. So atmospheric sciences are sciences dealing with the atmosphere, the Earth's atmosphere. However, atmospheric sciences are in general more broad than climatology. Not all regions of the Earth's atmosphere are particularly relevant when discussing the climate. So, you got people who are going to be studying the solar wind and how that influences the atmosphere. That is not particularly related to the climate, but they're still going to be atmospheric scientists. So climatology is a subfield of atmospheric sciences. And also, let's distinguish between meteorology and climatology. Meteorology is primarily concerned with weather conditions or weather trends on a basis of several weeks, and also about making predictions within the coming several weeks about the weather conditions. Climatology, on the other hand, has a much longer time frame. Climatology is looking at climate conditions over the course of the entire history of the planet, although that's very long. So more relevant are time frames in the hundreds of thousands of years, thousands of years, and even millions of years, which is out of the scope of meteorology. So climatology is more history of the climate on this planet. And remember, climate is weather conditions averaged over a period of time. So it's not the history of weather, it's the history of climate, which is of course related to the history of weather. So climatology is a branch of atmospheric sciences, and it's a subfield of physical geography. So geography is the study of Earth and its features, and of the distribution of life on Earth. Particularly, notably, is human life. Geography is separated into two major branches, physical geography and human geography. Human geography deals with the study of humans and their interaction with the environment, cultures, locations of humans, etc., how they migrated across the planet, etc., etc. Whereas physical geography concerns the processes and patterns in the natural environment, as opposed to how humans interact with the environment. So what is the environment doing naturally? What are the surface features of the environment, etc.? That's physical geography. And climatology is a subfield of physical geography. So what is the climate doing is related to what is the Earth doing naturally, okay? So climatology is a branch of atmospheric sciences and a subfield of physical geography. All right, a brief history of climatology. I'm going to pause the video and resume with the brief history of climatology because I'm at 9 minutes and I'm not sure if I'm allowed to upload videos longer than 10 minutes, so if so, I'll combine them, but I'm going to pause right here and resume. Alright, let's continue with our brief history of climatology. Now this is a very brief history. I'm sure there's a lot more that could be said about the history of climatology, but it kind of gives you an idea of the timescales that people have been studying this stuff. So in the 1100s, a guy named Shen Kuo finds petrified bamboos in a place where the climate is unsuitable for bamboo, and this guy realizes, hey, this is evidence that the climate changes over long periods of time. And then in the mid-1600s, a guy named Edmund Halley publishes a map of the trade winds, And the trade winds are just general wind patterns across the surface of the Earth, particularly over the oceans, which were used by traders to navigate the oceans. And that is related to the climate because the climate includes wind conditions. Okay. In the 1700s, Benjamin Franklin maps the Gulf Stream. The Gulf Stream is a general flow of water in the oceans, particularly in the Gulf of Mexico and the Atlantic coast of North America. The water flows from the Gulf of Mexico up the Atlantic coast because the water in the Gulf of Mexico is very warm. And so in the 1700s, Benjamin Franklin maps the Gulf Stream, which is related to the climate. In the mid-1900s, a few generations ago, a guy named Helmut Landsberg from Germany incorporates statistical analysis into climatology in English for the first time, which begins its evolution into a physical science. So ever since then, there have been climatologists doing studies, doing research, fitting models to their observations and doing more climatology. But climatology has only been considered a physical science for a couple or a few generations. So it's a relatively new science. Now let's talk about the approach to studying climatology. So climatology is difficult to study because of the long time periods and complex processes that govern the climate. In general, climatology seeks to reconstruct past climates by using historical records such as fossil records, tree rings, and ice cores. And the climate is governed by physical laws, so the laws of physics, and therefore can be attempted to be modeled by mathematics. So mathematical modeling is relevant and present in climatology, and I'm sure that we'll be discussing some of those models, but not today. And let me just go on the record as saying that right now I'm more concerned with getting as much information as possible as opposed to getting as reliable of information as possible. So I'm trying to get a broad overview of climatology. And once I have a general understanding of the field, then I'm going to go in and do more detailed, more academically rigorous research into the methodology and stuff. But as of now, I'm mostly just relying on Wikipedia for my information. So specifically the Wikipedia pages about climatology, the climate, the atmosphere, atmospheric science, physical geography, etc. And right now, I'm focusing a lot on learning terminology because I believe that understanding the terminology is one of the most important things in learning a new set of information. So, giving you a lot of definitions. Alright, so let's talk about layers of the atmosphere. Okay? So, the atmosphere is generally considered to be divided into 5 layers. The layer closest to Earth is called the troposphere, and it is about 10 to 20 kilometers high, and it's the smallest layer of the atmosphere by far. After the troposphere, you have the stratosphere, which goes to about 50 kilometers or higher, so approximately 15 kilometers to 50 kilometers, so it's about 35 kilometer distance. as opposed to the 10 or 15 kilometers of the troposphere. After the stratosphere, you have the mesosphere, which goes from approximately 50 kilometers to 100 kilometers. And if you want to know these in miles, just go to Google and type in 50 space km space 2 space miles, and it will tell you. So the mesosphere goes to about 100 km. And then you have the thermosphere, which goes from about 100 km to about 600 km. And these are really rough estimates, but it gives you the idea of the scales involved. I'll try to put a diagram of the layers on the screen, but we'll see if I can figure out how to do that. After the thermosphere is the exosphere, which starts at approximately, very roughly, 600 km and goes to about 10,000 km, where it merges with the solar wind. And the solar wind is not a layer of the atmosphere because it's not bounded to the Earth by the Earth's gravity. Okay? Now, beyond these 5 primary layers, you have what I'm not entirely sure may or may not be considered layers of their own, but they're a lot smaller, and there's 4 of them. Above the troposphere, you have what's called the tropopause. Above the stratosphere, you have what's called the stratopause. Above the mesosphere, you have what's known as the mesopause. And above the thermosphere, you have what's known as the thermopause. And these are regions where the temperature is essentially stable. So, in the troposphere, right near the surface of the Earth, you have the hottest temperatures in the troposphere. And as you go up, temperature decreases with height. Well, once you start getting to the tropopause, the temperature begins to flatten. And then once you get into the stratosphere, the temperature begins to increase once again. So I believe that these layers are primarily defined by their temperature gradients. So the troposphere would be where the temperature is decreasing with height, whereas the stratosphere would be where the temperature is increasing with height. And then the tropopause and the stratopause are regions where it's going from increasing to decreasing, or vice versa, where the temperature gradient is essentially 0. So I'll try to put a diagram of temperature relative to height, if I can. And so the temperature decreases with height in the troposphere, it increases with height in the stratosphere, decreases with height in the mesosphere, and then it increases again once you get into the thermosphere. And I'm going to pause the video again because I'm at 9 minutes, and I'm going to continue with a more detailed discussion of the troposphere. Okay, so let's talk a little bit more in detail about the troposphere. Now remember, the troposphere is the lowest layer of the Earth's atmosphere. So the troposphere ends between around 10 to 20 kilometers high, and it contains approximately 75% of the mass of the Earth's atmosphere, so clearly it's the densest layer of the Earth's atmosphere, as you might expect. And the troposphere is where all weather events take place. Also, the troposphere contains 99% of all aerosols and water vapor. Aerosols are liquid droplets or solid particles which are suspended in air. So smoke is an aerosol because smoke is solid particles which are suspended in the air. And mist is a aerosol, because mist is liquid particles suspended in the air. So the troposphere contains 99% of all water vapor and aerosols. And water vapor is just water in gaseous form. The troposphere is thinnest at the polar regions, at the North and the South Pole. The troposphere is thin, and then near the equator, it's much thicker. I'm sure we'll eventually talk about the reason for that, but I don't have that info for you today. And then they refer to the lowest part of the troposphere, lowest in altitude. They refer to it as the planetary boundary layer, and that is where the Earth's surface influences airflow. So that's the planetary boundary layer. And like I mentioned earlier, above the troposphere is the tropopause, where the temperature goes from decreasing with height to a flat, a consistent, or a flat temperature, okay? And then once you get in the stratosphere, it begins to heat up again. The chemical composition of the troposphere is essentially constant throughout the volume of the troposphere, disregarding water vapor. Water vapor is not as uniform as the rest of the chemical composition of the troposphere. Okay, and the last thing that I would like to talk about in this video is the chemical composition of, quote, air. So this is probably, I'm not sure if the chemical composition is uniform in all of the different layers of the atmosphere. All that this says is the chemical composition of, quote, the air. But I'm sure that this is quite relevant to the troposphere, considering that the troposphere contains 75% of air. Okay, so the composition of, quote, air is 78% nitrogen, 21% oxygen. Now notice 78% nitrogen and 21% oxygen covers 99% of all of the components of the air. And then you have 1% argon. So notice that nitrogen, oxygen, and argon make up approximately 100% of the atmosphere. In fact, nitrogen and oxygen make up approximately 100% of the atmosphere, with nitrogen being approximately 80%. All right, and then you have very minute levels of other molecules in the atmosphere. Particularly worth mentioning is CO2, which is 0.04% of the molecules in the atmosphere. So less than 0.1%. And I believe that scientists generally refer to the concentration of CO2 as 400 parts per million, rather than saying it's 0.04%. Okay, and that's all that I wanted to talk about in today's video. I'm going to go ahead and do more research and bring you my findings in the next video, which will be in approximately a week. So thanks for tuning in. I hope you learned something, and I will see you in a week.